Hello and welcome back. I wanted to give a quick overview about how I test 6502 code with behavior driven development. So, say for example, I have this source file. This source file defines a macro, or a couple of macros, which contains some code to first initialize a bubble sort routine and then to execute a bubble sort routine. This bubble sort uses an index table approach where the values are actually not swapped. The values inside the index table are swapped instead for the sort that's carried out. And also I have this quicksort source file, which also defines a couple of macros for initializing and then executing a quicksort. Now the quicksort algorithm should be a bit quicker than a bubble sort. However, a quicksort and a bubble sort have different pros and cons, and they have their different use cases depending on the type of data and how much execution time you have in terms of constraints. So what I could do is that I could have some source files which I can assemble by hand on the command line, and then I can call the initialization, or then I can load the PRG files up into an emulator, and then I can call these entry points, and then I could manually validate the memory addresses to make sure that they are behaving correctly. However, this approach is obviously manual and fraught with problems. It's not very efficient, but it's also risky because manual tests are not precise and not repeatable enough. So what I use is that I actually tend to use my BDD 6502 framework. Now when I use my BDD 6502 framework, I can define test cases. Now these test cases use a high-level syntax language which is really easy to understand even for someone who is not particularly technical. They don't need to know how to write Java code to create this syntax, because this syntax is actually, some of it is actually macro-based syntax. This macro language actually allows me to create step definitions for test scenarios by combining lower level step syntax which is defined in Java code. So using this method means that somebody who is going to find it difficult to maintain Java code can reuse existing low-level Java code steps, but then group them into higher level functionality and then expose the new syntax for use inside a standard feature file. When this feature file is executed, actually what it does is that it builds some of the code first. When it's building the code, for example, it uses build, sort, test, and then it passes through a type. This type comes from the examples table from the type column, and it either chooses bubble or quicksort as it's executing this scenario outline. So the type comes through to the macro here. Build, sort, test has a standard parameter. And this parameter then gets fed through eventually to the end of the build command line here, where it uses $1 and it chooses to either assemble or build rather check sort quick or check sort bubble.a, and this corresponds to check sort bubble.a and check sort quick.a that we saw here for the unit test harness. This code all gets assembled using a standard run the command line with the Acme assembler here. It's pulling in all of the different library files that it could depend on. It's defining the output prog file or PRG file to save it as. It's defining how the label file should be dumped. It's defining the type, in this case it's CBM for the output file format, and so on and so forth. It then tells the internal 6502 emulation core to load the PRG file and load the labels file. So all of this higher level syntax, because it uses the lower level syntax which exists inside Java, it can abstract away all of this slightly more technical code and make the test a lot more readable. So when you actually run the test, this macro level parsing for the feature file is actually done internally inside the Qux+ framework, which this BDD 6502 framework is actually built on top of. The Qux+ framework is something that I've been building and maintaining because I've always, for a long period of time, been very interested in using BDD to do unit test validation, performance test validation, and so on and so forth. And we can see here that this scenario outline is executed the code twice because there are 2 rows inside the examples table. And we can see here that if I refresh the report, then this is the standard Cucumber report that you would get. It's the default level report, and we can see here that the first scenario outline executed everything. Now the Cucumber report details all of the steps that come from expanding all of the macro definitions within the feature file. So we can see here all of the steps that were executed. You might notice that I'm using some of the step syntax here which says I expect the cycle count to be no more than and a particular parameter number of cycles. It's getting this from here, or here, or here, depending on where I call it. And in these different circumstances, this is the way that I can define the expected performance of the code. So these lines here, they validate the expected behavior, the expected descending stable sort index table, for example, and the expected ascending sort values table. These are behavioral expectations for the test scenario, but this is an expected performance behavior for the test scenario. This allows me to make sure that any code changes I do to the assembly code do not negatively impact the performance of the code. I don't mind if something is faster, but I really do mind if the code is a lot slower, because I don't want the code to be slower, because other games, other projects depend on that code to have certain execution constraints. Now, of course, even if this is executing a less than sort test, we still expect the sort values table to be untouched. We just want the sort index table to be descending to match the less than sort. The macro syntax, which is actually defined here, actually comes through in the overall syntax report. So we have a table of contents for the syntax report, which is automatically generated by the framework, the Qux+ framework, and I can click on here and it will give me all of the syntax which is defined. Now, some of this syntax comes from the Java code, some of it does not, but we can also click on the grouped by functionality and sorted without keywords. So this glue code is actually, most of it, in fact all of it, is defined inside the Java based framework. So all of this code here is to do with starting and stopping the virtual 6502 or 6510 machine. It's to do with initializing different graphics layers and stuff like that for display. It also allows me to execute command line and stuff like that. But the great thing is that any of the macro code also comes through in the report as well. So given build sort test is one of the macros that we were having a look at just now. When executing the greater than sort test, for example, we go back here and we can see when executing the greater than sort test, and we can see that it resets the cycle count and then it uses the Java based syntax to execute the procedure at sort GT, which is short for greater than, for no more than 10,000 instructions. So we can use this macro functionality to compose more readable test cases, but more maintainable test cases too, because the technical capability level for using these macros is a lot different to somebody who could have a technical capability level of understanding how to maintain or create Java code for step syntax. In this way, we can allow a broader, wider audience with a more varied technical competency level to use existing lower level syntax or to maintain easier to understand macro level syntax. And this helps to improve the number of people who can actually write test cases. Of course, I don't have to execute the test cases from within this Web GUI based interface. The test cases are actually just, as you would expect, text files. The macros are also, as you would expect, text files. I could just, for example, run this batch file, which calls the Java code. Actually, it's a jar file, which is obviously compiled Java, and it's got some extra stuff like defining where to pick up the macros from, where to pick up the glue code from, which is the test glue namespace within the test framework. And I can just run the test like this, and then the test execution framework will return 0 or -1 or 1, or depending on the error level. And in this case, it's returned 0, of course, because the two scenarios passed and there were 152 steps executed. These 152 steps, of course, come from the full expanded macro file, which is part of this scenario outline here. We have 152 steps in total here. But the original source file for the feature file doesn't obviously contain so many steps. This makes the original unexpanded feature file a lot easier to read and a lot easier to maintain. This defines very much the high-level behavioral and performance expectations for this code. But being able to execute it from the command line means that during a build test execution environment, I could include this in terms of a build system. I could look at the return result. I can use all of these generated test reports, and then I could archive up the test reports. I could send the reports to some kind of Elasticsearch based reporting backend, which would allow me to store, for example, the test reports and any passing or failing metrics from those test reports, and then view the historical data for these test reports, for example. You could do all sorts of things. Now, of course, you might be wondering, well, this is fantastic, but how did you manage to hack around Cucumber to be able to support macros in feature files? And it's not particularly easy. The Cucumber code, especially if you are just working with the Cucumber jar files, is relatively complex. And of course, if you're using jar files, it's quite opaque. But the next video, I will be going into some more technical details about how you can use Aspect J, which is what I use, to weave some of your own code to deal with expanding macros and to deal with modifying the reported data, or weave it back into a regular jar file that then you can then use in other applications to allow this kind of extra functionality. There's a few different entry points that you really want to try and trap within Cucumber to enable all of this functionality, and there are 3 ways of doing it, so I'll go into the more technical details for this in another video. So there we have it. This is just meant to be a short demonstration video on how I use behavior driven development to test my 6502 or 6510 based assembly code. Thank you for watching. If you like these kind of technical videos, then please do consider liking or subscribing to this channel, and I hope to see you around next time. Have a great day wherever you are.